On this virtual bus tour, we'll be travelling up the coast from Mackay in the Central District to Mossman in far north Queensland. We'll visit over a dozen sugarcane farms and hear from growers and other experts on the steps they're using to monitor and improve the quality of water that enters and leaves their farms.
I'm Adam Connell, I'm the project officer for the Water Quality Pixel project. Our project monitors water quality on 60 growers' farms in the Burdekin. It's a grower-driven project. They do all the monitoring themselves and we just coordinate the project for them. So basically the project involves growers monitoring the water quality entering their farm and leaving their farm in the irrigation to reduce nutrient levels leaving farms. We want to improve the water quality entering the local creeks, rivers and waterways and ultimately the Great Barrier Reef. Growers get a lot of benefit out of it because it reduces the amount of fertiliser they lose off their paddocks and they can monitor that, so it empowers the grower to be able to monitor what's going off their paddocks. We provide this test kit to the growers. The test kit contains nitrate and phosphate strips for testing water on the farm straight away. Here we have the nitrate test strips that the growers use. Basically there's one test strip in a packet, they rip it open, take the test strip out, dip it in their water and the test strip changes colour and then they just look at this colour chart here and get their reading for their nitrate level. The phosphate strips, the grower fills up that vial with some water up to the line and then they dip their strip in, the water changes colour and then they match the colour to a colour chart. That gives them an idea of their dissolved phosphate levels. The growers also given this field guide. It's developed by cane growers and SRDC. Gives them a lot of information about monitoring water quality on their farm. There's a lot of information in there and it just goes through step-by-step instructions on how to monitor water quality. And it's got a guide for what sort of levels they should be looking at coming off their farm in the runoff water. It's just an indicator for the grower. It's not an accurate reading, but it gives them an indication of what's coming off their farm and then the lab test will verify that level for them. The growers are provided with these bottles so that they can take water samples off their farm. We then send those water samples to the Mafia lab and they're analysed for nitrate and phosphate levels. It gives the grower an accurate reading of their nitrate and phosphate levels and we then feed that back to the grower as soon as possible so they can get an idea of what's coming off their farm. We also have a turbidity tube for growers that want to use those. That tells them how much sediment's going off their farm. Growers can also monitor the salinity in their groundwater with this electrical conductivity meter. All they do there is turn it on, dip it in their water, and it gives them a reading of how much salt's in their water. We also give the growers a field record sheet. It's on waterproof paper so they can get it wet and record all their results on there. They usually have 2 or 3 sites from each farm that they monitor and they put all their information on this sheet, which then we take back to the office and coordinate all that. Match it up with their lab results. Also on the back of this sheet the growers can record their fertiliser practices. We match that up to their water quality results and we use that to identify any issues that are happening on the farm.
So this is Dennis Posibon and Brian Stratty. They've been participating in the Pixel project for about 9 months now and they're going to show you how to use the monitoring kit.
Well, firstly we've required the water from my recycle pit. After we've rinsed the bottles out 3 times and the cup out 3 times, we fill it up with the water. And you can see it's 973, so we put here recycled pump, bottle number 973. Firstly I'll test the EC. Now these should be all calibrated. And the EC is 0.4 and we record it on the EC there. Secondly, I get my nitrate strips. I'm gonna dip it in for 2 seconds and I will just leave this out of the sun. Thirdly, I get my phosphate strips, and with this amount of water up to the 2 lines, there's a line there, okay. We put the strip in and we agitate for 30 to 40 seconds. As you can see, it's changing a colour there already. Okay.
That's 30 seconds.
Yep. Put the strip down there. Then we'll move it over to the chart here, and we'll actually run it across until what we think is the right amount of the colour. And at the moment it's sitting at 400. That's finished. After a minute, we're looking at the nitrate levels. We go back to our little strip and we can safely say that is between the 0 and the 2, so I'd say to be about a 1.
After we do all those other tests, we do a turbidity test. There's 3 lines on the bottom of this vial. Make sure you're out of the sun with it, and we just pour the water in it. Close one eye, makes it a lot easier to see, I think, until the lines disappear. And then we take a reading. Our reading is close to 80, and we fill that out in our field workshop sheet again and record it.
After we record the bottle samples, we'll usually put them into the eskies supplied and try to get them freezed into the freezer within at least 10 minutes, and then they'll come and pick them up at a suitable time.
So do you think it's a good project for other growers to be involved in, so they can help explain how their farm management practices affect the water quality? It helps you be able to know what's going on.
Definitely, especially if a farmer has got high nitrates. That's the main concern, I think, is just depending on how much water he needs to apply with the nitrate. If he's got high nitrates, well, why put extra fertiliser on?
Yep.
The runoff that does come off this block of green trash did actually go back into my recycled pit. With that, there was no runoff into the catchment area, and it does go back onto my blocks, and so I do catch my nutrients and the sediment, and it just gets recycled on my property.
I'd chosen a place at the back of the farm where I was sure that any of the influence in the drain, the influence on the water quality, was definitely going to be from our property. So it was somewhere that was central on our property. However, as the wet season rolls on, access becomes an issue, and you're carving up all the headlands and everything to try and get to it. So it probably wasn't really the best thing to do. So had a bit of a think about it. I thought, well, along this drain here would probably be just as good, because I have the influence from the road, but I'm going to need that road for access. That's very important. It's important to try and get there at any time of the day to try and capture the first flush waters. And that's not always possible. I mean, it can rain at any time in the middle of the night. I don't think anyone's going to get out of their nice warm bed and go measure some water in the middle of the night, but first thing in the morning, you'd be down here and taking a sample. It generally doesn't take that long to take a sample. By the time you take the sample and test everything out and put everything away, you probably have change out of an hour, I would say, out of your day. What growers need to remember is, after you've had a rain event, there's not a lot to do on the farm. Well, there's not a lot you can do. Apart maybe open some drains if you had a lot of rain, but generally you should have the time available to do a bit of water quality monitoring, and I'd recommend any grower get involved with that sort of thing. So if you're choosing your site, just to recap on that, make sure you've got good access. Make sure it's from a catchment area that you have some sort of prior influence or prior knowledge on what's actually gone on that land. And away you go. That should be about it.
So we've got 5 sites in, or 4 in the Lower Burdekin and 1 in Bowen that we're going to monitor, and we monitor them every 2 months, each site every 2 months, and then we look at how that changes over the course of a year or a couple of years, and that gives us an indication of how the pollution is at different times and how the species change over different times. So we use a net like this, and basically scoop it through the leaf litter, all different areas of the water. If this was flowing, we'd be scooping it through fast running water and also stagnant sort of pools, because you get different bugs in different areas. So if you've got waders, then you can get in the water, but it's probably not advised in crocodile country. And you just reach out a fair distance, put the scoop in, and just quick up and down motion like that. Up and down, and that seems to catch the bugs, so swim into the back of the net. And once you've collected your water, you take it up, drain the water out a bit, and then you pop it into your bucket. And then basically you just take that bucket and pour a little bit into your sorting tray and just sort from there, and just go through till you've sorted most of the bucket through. Kate's just found us a dragonfly larvae. They can get quite large, and that's probably a medium-sized specimen there. They're fairly tolerant to pollution. So here we have a damselfly larvae. That's a fairly large specimen there. They're about a 4 out of 10 for pollution sensitivity. And in here we've got a couple of bloodworms squirming around on the bottom, or non-biting midge larvae. They're fairly tolerant to pollution as well. Here we've got a typical water snail. They're quite tolerant to pollution. In here, swimming around there, is a water flea. They're fairly tolerant to pollution as well. Basically, you'd be searching through there for about an hour. Whatever species you find, we'd tick off on a checklist. And then once we've been searching through for an hour and we're confident there's nothing else in there that we haven't found, we add up the number of species that's in there, and that gives us an indication of the diversity, so it's species diversity. And the higher the species diversity, obviously the more healthy the waterway is usually. And also depending on the pollution sensitivities of the bugs, so bugs that are more sensitive, rating 9 or 10 out of 10. If you've got more of those than you do the more tolerant species, that gives you an indication. Basically add up the numbers for each bug, and the number you get at the end, say it adds up to 105, that then matches up to a pollution sensitivity index, and whatever that number is, that gives you an indication of how polluted the waterway is.
The paddock to reef monitoring sites in the Mackay Whitsunday are funded through the federal government, the Queensland Government, and also with some co-investment from the Coca-Cola Foundation. The aim of the trials to quantify the water quality benefits, the productivity and profitability of varying management practices from C to B and A class practices. As you can see behind me, these are our paddock scale treatments. We have 3 scales in which we're monitoring. We've got our paddock scale, our multi-block and our multi-farm scale. At the paddock scale, we're comparing treatments against each other, where at the larger scales we're just looking to measure water quality improvement over time.
So what we have here on this side is a paddock split into 5 treatments of about 18 rows each, and we're measuring runoff and water quality off 4 of those rows. So the equipment here is rubber belting directs water from 4 rows through a metal flume here, where we measure water height with a pressure transducer. So that measures water height with our metal structure, our flume. For a given water height, we know the discharge. So our data logger converts the water height flowing through the flume to a discharge rate. That accumulates discharge during the flow. We have an automatic sampler with the suction here. So for every 3 millimetres of runoff, the sampler takes a sample into a glass bottle. So this is our automatic sampler, so the sample from the flume gets pumped up, controlled by the sampler here, pumped into sampling bottles. So the data log accumulates our flow in litres, so 3 millimetres for these sites is approximately 5,000 litres of runoff. So once it gets to 5,000 litres, the data logger sends a pulse to the sampler. It puts a subsample into one of these glass bottles, resets the flow discharge counter, accumulates another 5,000 litres, puts another subsample in, does 10 of these for every bottle, moves on to the next bottle. So we get a flow weighted sample for each runoff event. We get those samples analysed for sediment concentration and nutrient and pesticide concentrations. All these sites are in a radio network, so when it takes the first sample, it sends a message to our base station, another site, which sends an SMS to us, so we know when it's sampling. What we're finding generally in a 1.5 versus 1.8 metre comparison is a reduced total runoff by approximately 20% from the 1.8 metre controlled traffic, and we think that's due to the decrease in soil compaction. For nutrients, generally find a relationship between the amount of nitrogen measured in runoff is proportional to the amount applied. Pesticides obviously depend on what's applied, and the way the pesticides break down, there's a degradation process with a half-life. So for example, for every 20 days the pesticide concentration left in the soil halves. What we've found is when we get runoff soon after application, our runoff concentration is very high, but they decrease very rapidly through the season. And for this site here, we didn't get runoff last season until 88 days after application, so it had gone through many of these half-lives, so the concentration left in the soil was only a small proportion of what was applied. So concentrations in runoff from all of these treatments, didn't matter what rate the herbicides are applied at, the concentrations in runoff were quite similar because of all those half-life processes.
A lot of the work we do, we're working in the creeks and the rivers, and whilst a lot of the focus has been on the reef, what we're finding is that a lot of the impact is actually a lot greater in a lot of those smaller streams. And so what our sampling that we've done has really shown that the catchments that have got quite high nutrient loads going into them have quite poor fish communities compared to pristine catchments, for example. And those fish communities are vital for what's happening out where people go fishing. So a lot of those freshwater areas are good habitat for fish to grow up in. And so you get a lot of fish like juvenile barramundi, mangrove jack, mullet, those sorts of fish species move up into those freshwater areas when they're young. So they move in when they're probably about an inch long, 25 mil long. They stay there probably until they're about a half metre long. They feed on a lot of the other fish species that are in there as well, and they just use that whole area as a nursery area to grow up in. Probably really good examples of some of our fishways. So we've got fishways that allow the fish to move past weirs. So when you build a weir, it stops the fish moving. So we put a fishway on it. It's just like a set of underwater stairs for the fish. We've got a fishway on Reliance Creek. During the peak migration of empire gudgeons, which are an important food source for barramundi and things like that, we get around about 300 fish a minute going through one slot of the fishway. So, and that happens for 24 hours a day for a week. So do the maths on that. That's a massive number of fish that are moving. On some of our other fishways, we get probably about a dozen barramundi a day going through, the juvenile barramundi. Now, obviously, they don't all grow up to be big barramundi. Life is life sort of thing. But I mean, in those lower water holes on some of those creeks, it's not unusual to pick up 10 to 50 sort of barramundi. From varying sizes, from quite small that have only just moved up to quite large, and those are fish that are ready to go back downstream and breed. So nutrient management on farms is really important. We've got a really good example, and we've got a bit of a project going at the moment in Reliance Creek. Reliance Creek's it's a small catchment. It's only probably about 15-20 kilometres long, the whole length of the stream. Probably around 60% of the catchment's cane. We have in Mackay, we have big storm events in sort of October, November traditionally. They tend to drop about 1 to 6 inches of rain in a very short period of time, and then we've got a fine sunny day the next day. And so what happens is you have a big rain event just at the end of the cutting season. So you've got a lot of sugar left on the paddock, you've got a lot of dunder left on the paddock after application of dunder. You have a big rain event comes down at that time, washes it into the creek, but because it's a short, sharp rain event and there's no follow-up rain, it goes into the creek and sits there. It doesn't go anywhere. And so what that does then just ferments in the creek, and within a day or so of that event, you'll have fish kills occurring because the dissolved oxygen is just plummeting in those systems. I think if we can capture the nutrients on the farm, and so what we're looking at with the local NRM group is installing a whole bunch of first flush capture devices to try and capture those first flushes so that the really crappy water is held on the farm and then pumped back onto the paddock and allowed to soak in. That really, does help the local streams not have anywhere near as much nutrients in them and keep the water quality a lot higher so that we can get through to the wet season. And once we have that, the wet season rains, that sort of tends to flush the whole system out. We have a lot of breeding going on at that time, and the fish numbers go right up, and then they sort of drop down again over the coming dry season. But Australian fish are just quietly incredible. They're able to deal with the highly varied climate that we've got. They've got remarkable adaptations. They'll breed up in a water hole. As soon as the rains come and there's water everywhere, the fish spread far and wide. It's just incredible. I mean, they just go as far and wide as they possibly can to every single water hole in the catchment, and they'll sit there, and as the water levels drop back down, they'll stay there. And what happens is that this side of the catchment will dry up this year. All those fish die. It's a natural process, that's what happens. But the fish that are over here will repopulate that area next year. And then when that area dries up, these fish will be able to repopulate that area. So there's a lot of that sort of going on. And because they are so adapted to that sort of natural environment, when we improve the water quality and do things like that, they come back really quickly.
Well, yeah, this was, there was 56,000 acres here that King Ranch actually bought from the government, from the state government. And they developed it as coastal fattening lands for their the stations that they owned out in the Western Country. And when they got this country, they clear-felled it. They used D9s and ball and chain and cleaned it right up. And they drained all the little wet areas, not the big lagoons like this, but they drained all the wetter areas. And they planted the wet areas to pastures that like panikin grass and that the cattle ate. And then when they decided to get out, and the banana farmers and some cattle farmers bought some areas, half of it probably went to the sugar industry. There was a riparian zone replanting, and if you look around the sides of this these lagoons and that, well, there's probably about 20 or 30 metres of riparian zone that's been re-established. That's for continuity of, for the animals and that to go from one place to the other, as they say, to migrate. That feature over there, that's called Sharon Creek. That's flowing into this one that's running this way, and this is Warramie Creek. And then Warramie Creek are probably about 300, 400 metres down towards the east here, flows into the Murray River. And this feature here, that's the Kimball 1, I think they call it. That's the first sand trap come fish habitat that was man-made to protect the natural Kimball feature. And we will walk up a bit further and show you Kimball 2, which is actually doing most of the work. You can see how effective these lagoons are. You can see the sand is being deposited here, coming from upriver. And we clean this out once a year, and after the major flood events it deposits all the sand here. Now this sand here used to end up in the natural feature down where the weather stations were. There's two stations here, the fixed stations, and there's a floating weather station in the middle of the lagoon, but between them all they monitor rainfall, wind direction, turbidity, radiation, temperature at the top of the lagoon and every metre down to the bottom, the flows. The local Indigenous community up here, they come down and they actually take some samples manually and get them sent away to get analysed, because they wanted the local Indigenous community to be part of this project, because this is their traditional lands here. This is where they come down into these areas, and they've been they come fishing here. They catch barramundi and turtles and eels and all that sort of stuff. Now these sand traps and fish habitat areas that we created, we've probably got 40 plus of those over this Riversdale-Murray scheme area, as well as a lot of culverts and that were converted from the old round pipes to square box culverts to assist fish passage when fish migrate from down below up here to do all their breeding, and then the young ones drift down with the flows when the floods start. I look around here and I look at the condition of the water, I look at all the little fish, and I see all that, and I can't understand the thinking that we are ruining, degrading the environment.
We're standing on the banks of Calamia Lagoon. It's a large water body on the Calamia Creek system. We've initially cleared Lilliesmere Lagoon up near Calamia Mill, and Lilliesmere Lagoon is now under management, Council's management program, with 11 landholders and CSR partnering the project. The idea of this work on Calamia Lagoon is that it's the last freshwater lagoon on the interface with the salt. The saltwater system has been identified through science as a high quality fish breeding nursery, and so the idea is that we now work on Calamia Lagoon, clear it, and then move up the system towards Lilliesmere to create fish passage. Prior to the water boards coming into being to provide water to the cane farming industry, these systems were subject to natural dry down each year, and in that case declared weed infestations or introduced weed species never ever had the opportunity to take over the systems. Once the natural waterways were used for irrigation delivery systems, they were kept totally wet 12 months of the year, and these invasive species then took over. What you see here on Calamia Lagoon, an area of open water. We've cleared through funding with NQ Dry Tropics, the aquatic weed harvester and an excavator. We've cleared all this open water. Prior to the clearing, it looked exactly like the Kumbunji or typhus in the background. It was totally covered by that floating hydroponic raft of Kumbunji. And prior to the Kumbunji taking over the systems, the hyacinth that you can see in the foreground here, the hyacinth and salvinia is another declared weed. They take over the system and blanket cover the surface. And then you have your rice grasses, your sedges, your paragrasses, your hymenacne. They form hydroponic rafts covering the hyacinth. Once the whole water body's locked up, then you get the typhus or Kumbunji, and further to that you get melaleucas, all hydroponically supported on the systems, picking up nutrient and soil particles. What happens then is when the floods come through, the floating rafts simply rise with the floodwaters, and you never ever get natural stream flushing like we've had historically. So what we found on Payard's Lagoon, it was the case study. What we found on Payard's was that there are only 5 fish species that could survive, and 2 of those were introduced species because they were surface brooders and surface breathers. So there's only 5 species. Within 6 weeks of clearing Payard's Lagoon, wave action, reoxygenisation, we found that there were 17 species moved back into Payard's. So through the science, fish surveys prior to, water quality monitoring prior to and post-harvest, we know that what we're doing is environmentally sound, and that we're on the right path. It's just to develop a process where we can manage these lagoons for future generations and maintain them after we've spent the big dollars. History now shows once we've cleared some of the systems, and we've got Healy's Lagoon, Horseshoe Lagoon, Sheep Station Creek, Lilliesmere Lagoon, and we're now working on Saltwater Creek and this one, Calamia Creek. History now shows that Salvinia is normally the first declared weed or introduced species to come back into the system, and Salvinia can cover an entire water body in 4 to 6 weeks. There is an introduced weevil, and it does work very well on Salvinia, but the weevil is always playing catch up, and the infestation takes over before it's killed by the biocontrol. So Salvinia locks the system up, the water body up, and following that, your hyacinth comes in. Your hyacinth can double its own weight every 12 to 14 days. So it doesn't take very long for hyacinth to muscle out the Salvinia in the system. That's your second line of attack. Following the hyacinth takeover, You have your native potato vine, you have sedges, paragrass, hymenacne, alamain grass, and rice grass as a tertiary infestation, and that really locks the system down so nothing's ever going to budge. Doesn't matter what sort of flooding you get, they just don't budge. What happens then, all that is supported hydroponically. The hyacinth collects the soil particles in the roots. Then you have plant decay and organic loads drop into the bottom of the systems, and all our lagoons now are very shallow lagoons, where farmers remember 30 years ago that they were very deep water lagoons, and we are hoping that flushing, once we clear them, that flushing will occur, and we will get back to some of those nice deep water holes that can support the barramundi and the mangrove jack, etc.
The field here behind us on my left was about a hectare of land, which was a bit of a nuisance to harvest, and the only way to add it to the existing field would have been to pipe this natural waterway here, which I didn't think was really such a great idea. Due to the other wetlands in the area that and my neighbours that have been very successful, I decided to speak with Terrain, and with their help we're going to create a fairly good wetland here, which will work in conjunction with my neighbours.
The treatment wetland, it's going to be all up in the end. We're looking at about 0.7 of a hectare. It's going to be a series of lagoons. Initially we're going to have a sediment basin, which will then drop into the first treatment pool and then into a larger, shallower zone, which is basically going to be planted out with aquatic macrophytes, and we'll re-veg the edge of it with a view that then it's going to hopefully treat the water, see a significant increase in water quality, remove suspended sediments, and then from that one the water then leaves this lagoon flowing downstream into a second treatment lagoon that we've got down there. I guess with the planning process of this, we've ran it through the music modelling process, which is a program which has been specifically developed to look at treatment wetlands. From the model, we captured the size of the block, the size of the catchment, the soil types, the runoff that's coming into it, the overland flow. Then we use that, instead of just looking at it as a single wetland approach, we actually look at the whole treatment train. So we're using the wetland which is situated downstream from Peter's, this one here on Peter's property, as well as the small ones which are in the adjacent cattle property. So it's basically a full catchment approach. Instead of just looking at it as a one-off small scale wetland, we're actually trying to look at the bigger picture, trying to really look at it, and hopefully we can get some positive outcomes.
So the design of these constructed wetlands is such that it captures runoff from the production area and is treated through sort of natural biological processes as it moves through the wetlands. So you've got the inlet zone, which often has an area that can trap sediments that are coming into the wetland, and as the water comes from the farming system down, for example, like the grass swale there, that's slowing the water flows down, and once it hits the wetland and you've got the large body of water there, it slows the water down even further, which drops out any of the sort of coarser particles. And there are two deeper basins up either end of the wetland. The first one's just around this area here, and that's approximately 1.5 metres below the normal bed level of the wetland, and that functions as a refuge for any sort of predators of mosquitoes, fish, dragonfly larvae and the such, to control that sort of mosquito pests, and also for when really dry times, the water will just be in those two deeper holes. And then the majority of the wetland area will be vegetated with a variety of wetland plants, reeds and the like, with a ring of larger plant species around the top, like your bottle brushes, lily pillies, melaleucas, things like that, to actually shade the edges to reduce any weed threats, the likes of paragrass and hymenacne. The shading will help prevent those from colonising the wetland. So when the water comes in, flows through that deeper area, and then evenly flows through all the reeds, they further slow down the water, and along the stems of all the reeds you get biofilms accumulating, and these biofilms capture other particulate matter, as well as it can uptake and transform nutrients through nitrification and denitrification processes to release that kind of gases into the atmosphere to prevent them flowing further downstream. The plants themselves also uptake the nutrients and other pollutants. Then the water continues flowing through the reeds into that other deeper area on the other side of the wetland, which is another refuge during dry season, and then it outlets down into in this case, the recycling pit that has been constructed. So the idea behind the wetlands is to have about a 2 to 3 day detention period for water moving through the wetland, to get that time for these biological processes to occur.
We're standing basically in the bottom of what used to be a productive cane field on a dry year. Property that we bought 2 years ago. Since we bought it, we've actually had 2 wet years, and subsequently we've lost the crop that was on this paddock. And we were looking basically for a way of managing this piece of dirt, making it productive and making it a more reliable producer, if you like, and had an idea prior to Reef Rescue funding of making it into a recycle pit or increasing the profile of drainage. And along came Reef Rescue, and we thought, well, it's a pretty good area for having a wetland. So made the approach, and excited a whole lot of people. Basically said, well, that's great, we've never had one of these in the Burdekin. I didn't realise that, but apparently it's the first of its type in the Burdekin. So the process started, and it's been quite an onerous process to get to this day where we're actually shifting soil. So yeah, we're basically going to build a wetland in here, remove the spoil, shift it across onto the remainder of the paddock, making the remainder of the paddock more productive and profitable, and also increasing our sustainability, the sustainability of our operation. The wetland will not form part of our irrigation infrastructure at all. We're going to keep our tailwater segregated from that, and as much as possible keep that water out of the wetland. Where the wetland will come into play will be on a wet event where we have an outflow from our farm, and what we're hoping to achieve is some pondage or slowing down of the outflows from not only our farm but from our neighbours' farms, getting that runoff to slow down and hopefully deposit some silts which may contain whatever they contain, whether it be herbicides or fertiliser. That's unknown, but we hope to just get that pondage and the slowing of the water flow through the property. Yeah, so what we've done as part of the process is we've partnered up with NQ Dry Tropics and NRM, and that opened up avenues to a whole lot of technical expertise that we didn't even know was there. And the wetlands was basically designed by a firm called Alluvium. Came down, inspected the site, and came up with a best fit basically, and we kicked around that concept with NQ Dry Tropics, Alluvium, and some other people that have been involved in wetlands up and down the coast. And we've come up with this meandering type design which takes into account the lay of the land, the types of soils that we're dealing with, what we hope to achieve insofar as revegetation and fish passage. They're all important things to have, and ultimately it'll be great to have. The objective is to have a productive area as well as a working natural environment, so that we can actually prove that the two can coexist together. What's basically happened over time, and this is well before I was a custodian of this land, is the natural vegetation has disappeared from here and pretty well around us, but we do have pockets below us and above us of natural vegetation. And the ultimate aim of this project is to have a revegetation project done so that we end up with a corridor that connects those two remaining areas, so that hopefully we'll have the native animals that used to inhabit this place coming through again. Part of the process of designing the wetland, we had to actually establish soil types and if there was any potential for acid sulphate soils. It has been identified that there is potential for acid sulphate soil. So what we've got here is the area is split up into 50 metre transects, and the laser operator's been instructed in how that soil has to be removed and how it has to be dealt with. He's actually removing it in areas and stockpiling it in its soil type, and it's being treated with the appropriate amount of lime for that soil type. The design itself, where we've identified the most potential for acid sulphate, we've redesigned the wetland and narrowed it and made it shallower at that point, so that we're not interacting with that acid sulphate as much as we possibly could have had we just gone and excavated that.
Now, a lot of these wetland plants are marginal plants. They go on the edges of constructed wetlands or dams. They're very useful in stabilising the soil. Their root systems, most of them are rhizomes, so they'll spread out and take over the area. They'll help stabilise the banks. Now, one of the first plants that we have here is Juncus usitatus. Seeds readily, as you can see from the flowers starting to form here. So those plants will actually seed and colonise fairly quickly. They grow to around about 60 centimetres on average, can be a bit taller. They can handle being inundated with water for a period of time. Next plant we have here is Leperonia articulata. Very similar, blades are a little bit thicker. Seeds readily, same thing, they will colonise an area. They can handle a little bit deeper water. So if you get a high flow coming through and it fills up, they'll actually be able to handle it. Same thing though, an edge plant, prefer it slightly moist but can handle drought as well. Next plant we have is Baumia articulata. These plants are absolutely fantastic for deeper ponds in your wetlands. Same thing again, they will colonise an area, they'll spread out and take over. The beauty of these plants though, even though they can be planted in deeper ponds, once a pond is completely dry, they will be able to survive. Once they're established, they're very drought tolerant. All of these plants that we have in our nursery, especially the wetland plants, are local to Mackay, but those three major plants that we've just gone through, they're almost present in every Australian state. So very common, most nurseries can stock them, but you're better off going to specifically a wetland grower who will have them in large quantities. You can either have them in tube stock or 6-inch pots or maybe 200 mils. The cost it varies a lot. Tube stock are a lot cheaper to put in. The only problem is with tube stock, if you have a lot of bird life in the areas around your wetlands, sometimes once you plant them, the birds can actually pull the tube stock out of the ground very easily. One of the other plants we have is Carax oppressor. This plant can be a little bit rough to touch. It can cut your skin very easily, but again, an edge plant, very drought tolerant once it's established, very hardy. If cattle accidentally do get in there and eat it, it will grow back very quickly. As well as a lot of the wetland plants do, they reproduce very, very quickly. So another fantastic plant. The same with this one, it is available in New South Wales, Queensland. It's one of the primary wetland plants that a lot of people use. This plant we have here is Chenoplectus muncronatus. Again, another edge plant. Can handle being sort of on maybe a mid-batter. They do like having their roots wet. They prefer a fair bit of moisture, don't like being dried out too much. Again, as all the wetland plants, they seed readily, so once you establish some, get an adult plant, they'll start colonising through your wetland. Absolutely fantastic, quick grower. The height, again, most of them grow around about the sort of 40, 60 centimetre mark, but it will vary on the conditions of your wetland and the water quality. So again, another good plant for your wetland areas. This plant here is Philodendron lanuginosum. These plants are very similar to the Baumea articulata in the fact that they can be planted in deeper ponds of your pools. On average, they get around to about 1 to 1.3 metres high. Very hardy, don't like too much drought, so they have to be in an area where it's always damp or have a little bit of water over them. Again, another quick colonising plant. Very thick bladed leaf, very tough and sort of succulent feeling to them. Again, perfect plant if you wanted somewhere to, maybe in a high flow channel of your wetland area, plant in there, and that will help stop any scouring out. When it's first established, these plants will take over very quickly. This plant is Lomandra hystrix, an absolutely fantastic plant for on maybe dry batters on the top of a wall of a dam or on a very steep batter. All Lomandras have a very fibrous matting root system, so they're fantastic for erosion control. It's a lot finer and strappier compared to some of the other species. Now Lomandra hystrix, they grow to around about 1 to 1.3 metres high, sometimes smaller depending on the soil condition. Lomandra hystrix can tolerate drought, inundation, so if it's periodically covered with a little bit of water during the wet season, it will be able to handle it. And Lomandra hystrix is very good at tolerating part shade. So if you've got a shady area that needs a bit of stabilisation, this plant is absolutely perfect for it. Very hard to kill, grows extremely quickly, the root system just is huge, it mats very quickly, as you can see. Very hard for us to keep them in the nursery because they just start pushing themselves out of the pots, want to get in the ground. Now this plant is Lomandra hystrix, a different species to the first Lomandra that we just saw. Again, very hardy, very large matting root system, so fantastic for erosion control. This plant prefers full sun. The leaves are a lot thicker and harder than Lomandra hystrix. Again, a very large matting root system, so we'll be able to stabilise soils very quickly. They prefer it a bit drier, but they will handle waterlogging as well as drought. The main species of tree that would go inside a wetland would be Melaleuca leucadendra. Most of the time they're available in tube stock. If you want to go a bit larger, they do establish very quickly. Now the Melaleuca leucadendra is one of your weeping paper barks. They look great. They can get up to 30 to 40 metres tall, but primarily in an area that isn't inundated with water all the time. They get around about 10, 20 metres. They will handle drought as well as being inundated with, say, a metre or so of water for at least a month or two. They can handle the wet season of North Queensland. This plant is Callistemon viminalis, one of the most popular shrubs that we have for riparian and wetland areas. Great for on your banks where it's a bit drier. They can handle a bit of moisture but not too much inundation. They can grow to around about 10 to 15 metres tall. Very hardy. If they got too tall and you didn't like them, you could cut them back. Say maybe a metre from the ground, you can cut them off and they sprout back very readily. Red bottle brush flowers, so you will get a lot of parrots and birds coming to land in these and feed them from them, and very popular. This plant is Syzygium austral. It's very similar to your Callistemon viminalis that we just looked after in height and size wise. Very hardy plant, produces round pink fruits. Lily pillies, they can be eaten, very popular with the older ladies who like to make jam. Can tolerate a fairly damp ground, very drought tolerant in the dry season. Same thing, again, if you don't like the height that they are, if you wanted to prune them, can easily handle being pruned. Very popular with birds that will come and forage for the seeds. This plant is Banksia robo, a very popular plant, Banksia family, so you've got your old man Banksia flowers. Can grow to the shape of a tree. Usually it's sort of a very ragged shaped tree, nothing really too straight. Beautiful flowers, attracts birds. Now this plant is a Casuarina equistifolia, which is a horsetail she oak. Predominantly it does grow on dunes in the coastal areas, but very handy if you wanted a nice weeping shade tree for around any of your ponds, dams, wetlands. Grows quickly, can tolerate drought, can tolerate moisture. Flooding on the other hand is a little bit iffy, so you might have to plant it on a high point. But if you can buy a tree when it's young that's got a nice straight trunk, you'll get a nice straight tree down the track. If you find it's got lots of branches at the bottom, it won't look as good. If you wanted it more to look a bit more like a shrub, I would go something with branches at the bottom, but if you prefer a tree, go with something that's got a straight trunk to start with. They can get to around about 40 metres tall, usually in a garden or sort of a constricted area like someone's pond. They will grow a bit smaller, so maybe 10 to 20 metres tall.
Things we do to reduce water loss out of the tree, and also to try and get the trees up above the weeds so we can come round later and spray, is we reduce the leaf volume by half by simply holding the stem on a hard bit up above here. Just lightly run our fingers down the stem and removing all the bottom leaves. So when we come and spray herbicide, hopefully the tree is up about this high and none of the leaves get affected by the herbicide. So the tree gets up, creates shade, and we don't have any problems with off-target kills, especially with our trees. So we do every little tree, hold. The Casuarinas are the easiest trees to do, but with your Melaleucas, you just have to be a bit more gentle. So go up and reduce the leaf volume by about half. So there we have a nice stem. Goes up tall, and it's ideally, I mean, we want lower branches for birds, but here we're trying to be a means to an end and get these up tall, create shade, and the natural recruitment of this tree's seed can then be the next generation of trees that will have low branches. We have a soil conditioner which has got fast and slow released fertilizers. The water crystals also are fast on release. The idea is basically we water once when initial planting, then in 2 weeks time, and then slowly try and wean the trees off it. So as the water table drops, the taproot follows the water, and then we can walk away from the trees. It just makes the trees hardy and tougher, and they can survive the conditions. If we watered every week, their root system would just stay here, and it makes them weaker when the wet season comes and this goes underneath. They'll just get washed away, and they're not anchored into the ground. As our water regime is, we try and be pretty tough on the plants. We put them in a bit of a well, so I'll just show you with. So we put them in here, roughly loosen them up. And in an ideal garden situation, you'd have them like that as a soil level. But here we make a bit of a well, so we bury them down deep. This way, when it comes to watering, we can get 5 to 10 litres in that well. If we planted level, that ground, the water would just dissipate out there and wouldn't soak into our root system and recharge our water crystals. This in turn, these stems can handle this filling up with silt and sediment, and they won't get collar rot. Basically any native tree you can do cuttings with will handle this situation. So that's a nice little well, and we can water and then walk away from it. Now, because we're on a slope, we want also to catch rainfall, but the water, make our little reservoir as big as possible. So we get all our remaining soil and make a dam. So that's just added to the height by about 50 mil. So and once that goes off, that'll retain a lot more water. So there we have a little dam basically where that tree we can water, and we can get a good 10 litres in that. All goes into the root system and recharges the water crystals.
Yeah, why we decided to set this artificial wetland up here, I seen that at a conference I went to as a segment on artificial wetlands, and I thought it was a great idea. And I thought, where could I implement that on my own farm? And some farms lend themselves to you being able to put artificial wetland on, and some don't. And this was a perfect opportunity where it was at the exit point of the farm, and it was a really good site for it. In the design of the wetland, I had a picture in my own mind what I wanted, and I ran it past the EPA, and they gave me some more pointers. They also had some requirements, like different depths that they wanted, and the exit points had to be at different places. So you don't just have water run in and water running straight out. The water has to meander through the wetland, and so the longer it's in there, it drops anything out before it exits back into the creek. The island is, that was an EPA requirement, so wildlife can go over there and nest over there. They can lay their eggs and raise their chicks over there away from wild dogs or dingoes. So that's the idea of that. And you see it, a lot of times you see young ducklings and stuff like that over on that island. We're really impressed with the wetland. There's a family of platypuses living in here as well, so which enhances it. We have bird watchers that come down and sit here, and like the species, we're up to 70 species of birds that live around here now, and it's really great. Everything sort of works in harmony with the sugarcane industry. The water flows in by the farm drain system where you see the pendamus plants. That's a drainage system along there. It comes in, I've got a tailwater pit pre-wetland here. The water actually hits a bank there, and any sediment, it drops it out into the tailwater pit, and then it by-washes each side of that into the wetland. Then it meanders its way through the wetland to the exit point here, and then we refilter it again through a rock filter down here as well before it goes back into the creek system. Underneath this concrete, it's all rock about that big, and it's got a bit of sand amongst it as well. So the water, about 3 megs a day, can actually go under this without even a drop of water running over the top. So it's filtered once again before it goes back in the system. This concrete, we had to make it rough, so actually it revitalised the water, put oxygen back in the water before it went back in the system. So that's why it's as rough as. Yeah, when it's a fair flow, you see about 100 mil of water going down here, and you'll see fish, 150 to 200 mil long, actually swimming up against it. We stand here and just watch them swim up against it and go into the wetland. Down the bottom here, what we've done, we've put big concrete blocks, so when the water goes back into it, it doesn't gouge out the bank on the other side. And I've got a wall there of concrete blocks. They weigh about 1.2 tonnes each. So the water just hits that, and it just sort of turns it back and puts it back into the creek. We zonal ripped where the trees went to give the trees the best chance of getting established. Then we planted the trees in probably about 6 weeks later, and they'll come in little pots. We planted them, we had to water them and mulch around all the trees, so it was a fairly onerous job to actually put all the mulch around it and keep them watered until the rains come. And we did it in January, which was pretty hot, so it was pretty hard going. We watered them by bucket with initial planting. Then we went through with a tanker and just watered them with the tanker every few days to get them established. And then about 4 weeks later we got rain, and sort of been looking after them since. Yeah, we mow the whole lot. We mow amongst these trees, the parkland over where the sign is and where we walked in, and also the trees over the other side, we mow between them as well to keep it maintained. Prior to this wetland here, we got another billabong back up towards the tea tree there, and it's about 4 metres deep. In the 1991 flood, it filled right up to the top with silt, so we had to get an excavator in to clean it out. Since then, it's probably still about 2.5 metres of water in that billabong. So since we've gone to green cane trash blanketing, it's very little to no movement at all off the farm, which is really impressive.
This is our constructed wetland. We put it in about 3 years ago, partly as a tailwater pit, but as a sedimentary detention basin. Now, as we did it, the drain was already in. It's a wet area anyway, usually constant spring water coming through it. So we dug this section out here to make the bank over on the left, and was actually the road, what was the road used to go straight through it. So we had to then put our road around the top of the bank, but that gave us a deep area at one end, and it runs back to shallow area at the top. I mean, you got a bit of bulrushes and a bit of paragrass and such, so we've got plenty of bird life. There's a few shags here, we've got the permanent home, so there must be some fish in here as well. It captures the water off at least 80 hectares of our cane,
It's been noticeable this last year where we did some work on drainage where any silt loss, well, the silt all ended up in here instead of out on the barrier reef or down the creek or whatever it is. So it's all, I mean, we can recover that soil and use it elsewhere for fill if we need to. So far, management issues haven't been too bad. We do have an issue with paragrass. First problem is paragrass incursion into the cane. I've found the simplest way to sort of relieve that problem is to keep those headlands slashed around the top. Paragrass doesn't seem to like going through that good slashed headland. And then, you know, it's sort of there's a bit of a program going on really to spray the paragrass back just to keep it suppressed. Probably never going to eradicate it, but just to suppress it out of it. Yeah, and it also seems to feed into our aquifer that our bore comes out of. So if we do need to pump the bore, it actually helps our pump what we can pump out of the bore, the yield out of the bore. So yeah, it's fairly cheap the way it's set up. It's pretty economical. It's not hard to actually pump out of it to use the water if we need to.
The wetlands, it covers an area here roughly, probably about 15 acres in here in total. You've got a tree corridor which runs along parallel with that nice spoon drain water path that you saw linking back towards our natural lagoon up against the mountain. We improved the sediment pond at the end of the tree corridor, which you saw. We added in from the local schools some owl boxes in there, which was much appreciated from the schools. We worked in conjunction here with the DNR, Productivity Board, BSES. We also got advice from our local wildlife guy here, John Young, and just brought all the guys down, went for a drive around before we started and feathered everybody's idea and then designed it up, planned it and went along with it. Like I said, Enviro Fund helped us fund it, Green Corps helped us plan it, and that's the name of all the young people that came and helped us. We've also put this with Bush Care, Land for Wildlife, and we've registered this area so that it can't be touched for any other purpose bar from what it's doing now. The soil that was taken out of this low-lying area here that had no trees was used on that lower half of the block. Okay, so we probably gained, you know, in certain depressions, we probably gained about 60 odd acres over on that side. In turn, we end up making water paths and islands from that soil. We snaked the water path all through these islands and trees, and this is the end result, and the outlet of that lagoon water path is out of here. The big thing is you can't be land hungry. You've got to be very careful and conservative on factoring in the percentage of land that you're cultivating on your farm to the percent of land that you're giving up for your water paths or for your wetlands at the end of the day, and look at the whole picture. If you're going to sacrifice 15 acres of ground here or 20, whatever it may be, but you're going to gain just on that side 60 acres of productivity, and on this side here you're basically branching back to the first road. It's roughly about 400 to 500 acres of farming land, and it's going to turn that around and improve that by about 3 to 4% in productivity. You don't even need to get a pencil out to work figures out. Better drainage, in the sense that with your drainage too, your headlands have got to be mapped in and tied up with your drills, because you need your longer drills to support the tonnes per hour that you need to be putting out now with these larger harvesting groups. So it's hand in hand with all of it really, when you look at it, eh? It was a little bit easy for us down this half here, being honest. It was new ground, and it was easy to remap and do. With existing farms, I would say, which we have done on our other older existing farms, there's a little bit more careful planning in the sense that you've got cane growing there already, and to remap it all, it's a bigger project to do. But it is possible to do. We had, with the thousands of trees that we planted, we had, I think, 2 big blue gums that were in the road on the paddock. So we traded off thousands of trees for taking out 2 blue gums. We recycled them basically. We trimmed them and we picked them up with an excavator, a big 30-ton excavator, and we've whacked them onto the side of the islands, branching into the water, basically looking like a mangrove, and it acts as a fish habitat. We've also, an average depth through the whole lagoon would be roughly about 5 to 6 feet. There's some retention holes there that are up to 12 to 14 feet deep to keep that temperature of the water cooler. so that, like for now, we're in a bit of a drought at the moment. If that water temperature in the middle of the day, which we're in now, seems to increase, well, those fish will retain to those holes. That was our plan, yeah. And the islands, they're also, some of the islands are totally surrounded by water. They act as great animal refuge in the sense that if you've got birds, whether they may be owls or curlews or whatnot, if they're laying eggs, they've got a better chance of survival because of the sense of being surrounded by water from feral cats or dingoes or what may be. It's basically all stitched in hand between, you know, what we're doing from a economical farming point of view to an environmental point of view. And in saying that, one day when I pass on, and hopefully my kids are here, if may be, and they're to take this place over, hopefully it'll be in as good condition or better condition than when we walked onto the place. And if not so, if the property had to be sold on to somebody else, at the end of the day, it'll hopefully be an attractive feature, an asset of the property to the buyers. And I think we've done that.
Yeah, okay, so this was a bit of a natural wetland. This was actually dug out and made deeper. There's 3 of these in this part of the property that catch the runoff, and vegetated all around the ends, and that's about all that we had to do. We've had to sort of keep some of the pasture grasses out, but apart from that, they've just grown. And I know they've done fish counts in there before. There's quite a lot of barra in here. So yeah, I suppose it acts as a breeding ground as well. So this drain here catches runoff from all of these paddocks, and it flows in. So that initially just catches all the sediment, basically. We've tried to design it so there's a number of drains coming into each pond and then going out again. So, okay, so we're just heading down to another environmental lagoon, which is sort of in the making, I suppose. This was cane land, as you can see over through to there, and the short road we found it just wasn't economical, so we took it out of cane production, and we've actually made the lagoon, and now we're just waiting for the right time to plant, I suppose. We've found over the years that revegetation is quite expensive, you know, and a lot of people underestimate the value of it, especially in the tropics. The biggest thing is, like with weed suppression, yeah, it can get very expensive. A lot of re-veg people only budget on, say, 2 to 3 sprayings, whereas it's probably a lot more than that, you know. So it can get quite expensive. Here we've kept it pretty clean because we can just blanket spray with glyphosate over this. But there's some panican grass there, and over the other side there's para grass and hamel grass. But if we can keep this as clean as we can and just keep on blanket spraying it, when we come in and plant trees, it won't be such an issue, you know. But that's the biggest thing with vegetation is weed management in these areas.